So um, this is a video to remind myself how to install sw4 on my home cluster. So sw4 is this seismic wave propagation simulation code um, developed at uh, uh, Lawrence Livermore National Laboratory uh, by Anderson and another guy, and it's a sort of fourth order finite difference method for solving 3D seismic wave propagation problems. Um, so that's sort of the GitHub page for downloading the source code for sw4, and it's got a bunch of files, right? So um, and if I look into the doc subdirectory, there's a installation PDF file that tells me how to actually install this particular package on my computer, on my computer cluster. So basically, all I have to do is to uh, first of all, I have to install all the compilers. But I think those compilers comes with my operating system. Uh, I'm using Ubuntu 17.10, so all those C compilers and also um, all those C and Fortran compilers comes with the system. And or if I want to sort of install them, I can just use Ubuntu's package management system, and then it also requires a MPI library, right? So I can also use Ubuntu's package management system to actually install this this MPI library, right? So that's not difficult. And then after the compilers are installed, I need these two linear algebra libraries, BLAS and LAPACK. Um, so what I did was to actually install a library that's called Openblasts. Right, Openblasts is a optimized BLAS library, right? Installing from source, so it's telling me how to actually install Openblasts. Right, it's an optimized BLAS library. LAPACK is actually built on top of a BLAS, so if I have a BLAS library, then LAPACK is not really a problem. LAPACK becomes quite easy. So on my machine, it's installed under mntgv0 brick, and then go to tools, so I can see my Openblast. Right. So Openblast is here. Right. The compiling process is actually really straightforward. All I have to do is to actually type make all, and then it's gonna automatically compile it for me. Right. And then the thing that's the library that's really useful is just this thing, lib openblast.a, right? And if I want to use the dynamic linking, then lib openblast.so, right? So if I just type a make, then it's gonna create those two files for me. So that takes care of BLAS, right? That takes care of BLAS. And then LAPACK, right? LAPACK. What actually surprised me is that Openblast actually automatically includes LAPACK, right? So that's the blog post combining Openblast with LAPACK. So this guy is asking. Uh, at first, I thought Openblast only provides BLAS functionality, but to my surprise, libopenblast.a library also provides LAPACK functionality. So it looks like a LAPACK is included, right? So and then some other guy was arguing if it's a complete LAPACK or something, right? It looks like it's a complete LAPACK, right? It's a complete LAPACK. So by default, it's gonna include a full LAPACK lib with some parts optimized, right? So it's not really a fully optimized LAPACK, but some part of it is optimized. Right, so that's sort of the default. When we actually install Openblasts, that's gonna be the default. And then if you don't want to include the laypack, you have to specify no underscore laypack equals to 1 during the make stage for Openblasts. Right. So by default, laypack is also installed. So this library actually includes both BLAS optimized and the laypack partially optimized. Right. So my BLAS and laypack are installed, and I have to sort of take a note about the path to those library files. Right. And then so then it says about unpacking the source code from the table. But there's one more thing that I need to do is to actually install the projection library, right? So it's let me see if does it say anything about projection. Of course, the projection library seems to be optional, but I prefer to actually use it. The proj.4 library, right? Um, Maybe this is kind of difficult to see. Can I actually maximize? Can I actually make the font bigger? Control. Yeah. So proj.4. This is a library for handling geographic projections. Right. Sometimes we would like to use different kinds of geographic projections for simulations at different geographic scales. Right. This one is actually quite useful. So proj.4, right? So Openblasts, that's one of those library files I have to install by myself. And then also underneath MNT GV0 brick tools, there's project 4, right? That's where I actually store my download of the source code. And this one is also quite simple. It's also quite simple. All I have to do is to type make all in order to actually compile everything, and all the libraries is gonna go into build, I think, right? All the compiled libraries are gonna go into build lib, right? That's all the libraries that's needed by sw4, right? So what I have to remember is that before compiling sw4, I have to make sure that I recompile both proj.4 and Openblasts in order to actually make sure that sw4 and all the depending libraries are compiled using the same compiler, right? So make sure that the compilers are actually consistent throughout all my stack. And then after proj.4 is compiled, all I have to do is to go to my sw4 installation directory, f3dwi, and then sw4, and then 2.0, right? 2.0. So this installation is for 2.0, right? In fact, the installation process is actually quite straightforward. It's not really as complicated as I imagined. It's so once I have those depending libraries installed, all I have to do is to actually edit one simple file, one very simple file, basic compilation, Mac machines, Linux machines, right? So all I have to do is to follow this particular step. Go to configs. Let me go to the configs. Right, and then underneath configs, there's a bunch of make dot something. Right, this something is actually the architecture. So if I'm on a Linux machine, so all I have to do is to copy this make.linux to make.inc, inc, right? So if I do cat make.inc, so this one is already modified, right? But the one that's before the modification looks like that, right? It's got like only 3 lines. I don't really have to change these two, right? GFortune comes with my Ubuntu operating system compiler stack, and then MPI-CXX actually comes from my installation of the MPI libraries. And then all I have to do is to actually change this line. That's external link flags. So that's what I have modified, right? Uh, I'm not exactly sure if this thing is still needed, right? The reason that in the original file this line is this portion is needed is because the LAPACK and the BLAS library, it assumes that the LAPACK and BLAS library was stored underneath this particular directory, right? But on my machine, it's not. It's not. It's actually instead underneath this particular directory, right? And that's my uh, that's my that's my BLAS and LAPACK library, right? So in fact, uh, I have to pay attention to the dependence here, right? Because LAPACK actually depends upon BLAS. So if I have two libraries separately, I have to sort of link LAPACK first and then BLAS, right? The dependence actually follows like a in this kind of reverse order. So the stacks that's the layers that's kind of close to the bottom are kind of appended later, right? So so that's my library directories, and then that's my library, right? Oh, but here I have to just link Openblasts because it has both LAPACK and BLAS libraries inside of it, functions inside of it. So I don't have to do this two. I just have to do one, right? And then I kept the LG Fortune, right, because it's gonna have to link Fortune. Some of the core routines of sw4 are actually written in Fortran, so I have to have a Fortran compiler. And then because the uh, uh, and then I have to do this thing. Um, so because in the documentation it says Fedora core 18, but Ubuntu actually looks quite similar. So I still have to do this dash WL dash R path thing. So the reason that I have to do this thing is because I'm not gonna use the library. I'm not gonna use the LD library path environment. Uh, I'm not gonna use this environment variable anymore. So this environment variable is actually empty for now, right? So if I do not specify this thing, then I will have to sort of specify LD library path, right? But this LD library path is kind of environment dependent. So if I sort of move my binary to a different place, I may have to uh, re-specify the LD library path. But this thing actually by doing this, all those paths are actually built into the binary. So so it's gonna automatically sort of look for those libraries, right? The binary is gonna automatically look for those libraries when it actually runs. So I think that's a better alternative, right? So and then all I have to do is to actually so everything that I've done here is inside of the configs subdirectory. So if I go back, then I will discover this make file. All I have to do is to sort of do make all, and then it's gonna create this optimize subdirectory, right? And then inside this optimize subdirectory, it's got lots of these kind of .o object files, and then the executable sw4, right? And by now sw4 is compiled, right? And it also runs fine if I specify the correct input files, but that's for a different video. So that's how I actually compiled sw4 on my Linux machine, and um, I'll 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 talk about the rest of the work later on.